Hey guys, my name is John Yi, and today I'm going to be talking to you about object-oriented programming. So let's get started. First off, I want to discuss what the four big themes of OOP, or object-oriented programming, are, how they work, and what they do. And then lastly, I'm going to do a live demo within BlueJ to talk about how these four are actually implemented and what they look like. So first off, what are the four overall concepts? The first concept is called encapsulation, the second one is inheritance, the third one is polymorphism, and the fourth one is abstraction. Let's first talk about encapsulation. So for example, if we talk about encapsulation, let's say we have a private class called human being. Now this class has private variables called height, weight, and BMI. These are all privated, so we can't access them directly. No other object can just call the height, weight, or BMI. But instead, what they can do to try to access these variables is the class of the human being could have public methods. These public methods are called setters and getters, and they allow us to access these private variables. If we want to access the height, we have a set height and get height. We have a weight, we have the set weight, get weight. And for the BMI, we have a set BMI and get BMI. This allows for other objects to access this object's variables, and it allows for a connection between the two public and privates. That sums up encapsulation. Next, we're going to talk about abstraction. Now, what abstraction really lets us do is it allows us to have lots of bigger, more complicated workings within a certain program, but it's not known to the user because the user doesn't care much about it. Now, it basically is an iPhone all summed up. An iPhone has many complicated workings within it. The hardware, the software, things that the common person doesn't really care too much about, and not even many programmers care too much about them. But what it does have is the outside functions, such as the home button, a lock button, and a volume button. Now these buttons allow us, the user, to easily navigate through an iPhone. When we click the volume up or down buttons, we expect the volume to change, and something within iPhone allows the volume to change up and down, but that's not something that we care about. As long as the function works, that's what matters. Another example could be a coffee machine. It does a lot of stuff and makes quirky noises under the hood, but at the end of the day, coffee comes out, and that's all that we care about. Because on a coffee machine, there's few buttons. When we click a button, that's all we want to happen, coffee to come out. That's basically abstraction in a nutshell. Next, we'll talk about inheritance. Now, inheritance is when you have multiple objects that are similar, but they're slightly different. What I mean by this is you have a herbivore, carnivore, and omnivore. All three of these ors are animals. Now, animal can be considered the parent class, and the herbivore, carnivore, and omnivore are considered the child classes. All these child classes have something in common. They're all an animal, and an animal has certain traits. For instance, they could have eyes, legs, a tail, the fur, etc. All of those can be put into the animal class, and then the herbivore, carnivore, and omnivore, aka the child classes, can just take from the animal class, so they don't have to retype them all out. And whatever is different can be implemented within these child classes. That could be said for the same thing for the rabbits, lions, hyenas, and man. A rabbit is a child class of the herbivore. The lion is a child class of the carnivore, same with the hyena, and the man is a child class of the omnivore. Now this is a multi-level inheritance structure, but for the basis of this presentation, we're going to be talking about single level. So for single level, we have a little soccer player, and soccer players have different positions they play. You've got the forward, the midfield, the defense, goalkeeper, and reserve player, or the player that's sitting on the bench waiting to play. Now all these players are soccer players, so they can grab from the soccer player parent class. That could be their name, their numbers, or whatever else a trait the player has that's common. What is different between these positions? Well, for instance, a goalkeeper can use their hands, so that wouldn't be in the parent class because not all players can use their hands. A reserve player is not actually playing, so that can't be in the soccer player as well. So these are just some traits that can't be in the parent class, but can be in the child classes. Lastly, we'll be talking about polymorphism. Polymorphism allows us to override methods in the parent interface. So we must create a parent interface that has a method that can be distributed throughout all the child classes. It's similar to inheritance and uses inheritance. Polymorphism is on a multi-level scale. So you have class dogs and class cats that utilize this make sound method. Class dog will override this make sound method, and it would be something along the lines of setting the dog's sound to bark or rough and the class cat's sound to meow. It's just overriding these methods, and that's what polymorphism allows us to do. So first off, encapsulation. So if you see here, I have a human being class right here. And within this human being class, like I said earlier, we have the height and the weight. For the purpose of the input the BMI, because it might take a little too long. So we see here that the human being has a height and weight, and we set those to private right here. Now along the line, we have this constructor that sets the height and weight to 0, just for the constructor purposes. And like I said earlier, we have the setters and the getters. Now I'll tell you why this is important and why we can't access them without these setters and getters. So we have these set height, get height, set weight, get weight. So this height will take this dot height and take this parameter and input it as the new height. Then this one just returns the new height. This one does the same thing but with weight. We take the weight, this dot weight, and we implement it with the parameter new weight, and it sets the new weight, and then we return the new weight. So now in our tester class, you can see how they're connected together. In our tester class for this human being, we have our main, we have a human being, new person, human being. This just creates a new person of type human being. So human being has the height and weights. So we have a new person dot height equals 65. This is what most people probably will do, but we can't do that because of encapsulation. We have set these private variables height and weight, so we can't just put new person dot height weight. It says height has private access in human being, same with weight has private access in human being. These will not work. This is why we have to have these setters and getters. So when we take those out and we have new person dot set height to 65 and new person dot set weight to 155, it allows us to set those new heights and weights. So now when we go ahead and we compile, we get no errors, and we run it, the person's height is now 65 and the person's weight is now 155, replacing the old constructor's 0 height and 0 weight. So now for abstraction. First off, we're going to go into this abstraction class, and we declare an abstraction class with the following. Instead of public class coffee is abstract class coffee, and we have one method here called make coffee, and this is also a type of abstract. Now that's all that's going to be in our abstract class, abstract void make coffee. And in our actual class coffee maker, we're going to have public class coffee maker extends coffee. This extends allows us to use this abstract class coffee right here, and it connects these two. So within our public class coffee maker, we have void make coffee, which again is the abstract method that we put in our abstract class, and we're overriding this make coffee method now with a system.out.println making coffee. So now that our make coffee actually does something, we can go into our main, which is right under the void make coffee, and it says coffee Keurig is new coffee maker. So again, Keurig is just of type coffee, which is abstract, but it's a new coffee maker right here. So it takes this abstract methods and creates it of a new coffee maker. And now we can call Keurig.makeCoffee, and it should print out making coffee. So we can compile this and run it. Now it says making coffee. So this is how you use abstract classes. Now we're going to talk about inheritance, which is right here. So we'll start off like we said with the parent class, which is an animal. So we have the animal class, and it has a number of legs and the type of sound it would make when an animal makes a sound. We have the constructor with the legs and the sounds, and we have this string to string method. This toString method just allows us to know what is in an animal. So we have how many legs does the animal have, and what does the sound of the animal make. So now this parent class leads to then this child class dog, and dog is of type animal, and that's why we have this extends animal as well. We can use everything within the animal class inside the dog class, because again, animal is the parent class. We could have named this anything else like cat or giraffe or whatever your favorite type of animal is, and we can actually make a new one if we wanted to. So we could call this giraffe right here. Just put this one here, and we can put extends animal and take all of this stuff out because we don't need it. Okay. So, like our dog class, the only difference in our dog class from an animal is our string fur color. You could put other things such as string collar type if your dog has a certain collar, and then obviously you would just implement it within the constructors. But for the basis of this, we're just going to use a fur color because not all animals have fur, and yeah. So fur color, we have the constructor. So with inheritance, we're allowed to use this super. So what super does, we just put super legs sound, and it goes back to the animal class and calls this constructor right here. So we don't have to retype out this dot legs equals legs and this dot sound equals sound. With super legs sound, it just calls this using inheritance, and we have this extends animal. Okay, so now we have a regular constructor with this dot fur color is fur color, and now we have a setter, which is public void set color string color. Fur color is color, public string to string. Now we have another super dot to string call. This super call again goes back to the animal and goes to this to string, so it'll call all of this right here, and then it'll go into the fur color right there. So let me just comment all this out real quick, and then we can delete this one, compile that. So now in our tester, to make sure that our dog works and it actually uses inheritance and does what we want it to do, we make a tester and we have a dog in our main. We create a dog one of type dog, and we give it, because within our constructor we said it was going to take in number of legs, the sound it makes, and the color of its fur. And just to make sure that they are different, we have an animal of type animal 1, a new animal 3, and a generic sound. So what we'll do is we'll take a system.out.println of dog1.toString. So what this should print out is this super.toString. So it'll go here and print out this first. Then it'll print out the fur color. So let's compile, run it, and we have what we want it to do. We have the legs of the animal, we have the sound it makes, and we have the fur color. Now to link this with polymorphism, because inheritance and polymorphism are connected, in our animal class we can give it a method called void animal sound. So in animal we have it called calling system a printout line that says animal makes a sound. That's what it will print out when we call this method animal sound and we make an object of type animal. In dog, we can override this method again, and instead of saying animal makes a sound, we can give it something called dog goes rough rough. So this is the sound that a dog will make. Compile this one, and then we go here. So obviously if we do dog 1, it's going to take the dog 1's animal sound and call this one right here. Animal 1 sound should call this animals and call this one. But what we can also do is say animal dog, and what we can do, animal dog 2 is equal to new dog. and we have to give it a constructor. So we can do for, we can say this one goes rough as well, and maybe the color is different, so we'll give it a color orange. And so when we call dog2.animalSound, it'll go to this animal and see the animal sound, but it'll show that it's of type dog. So it'll go to the dogs and it'll say dog goes rough rough. So we'll compile this one and run it, and as you can see, we have, it has for rough. The fur color is brown for this one. Oh, we forgot to, in our inheritance tester, we can do system.out.println dog2.animalSound, and we can comment out what we try to do for the inheritance one. And what did I do? Oh, dog2.toString. So our fur color, only thing that changed is orange. So when we run our inheritance tester, we have it as fur color is orange, dog goes rough, and so it works. So these are all tools used in object-oriented programming, and it makes life a lot easier. For instance, when we talk about inheritance, we don't always have to write out these things, and we can just call the supers. And in larger programs, it'll be very useful. In abstract classes, we can just have make coffees, and in our actual coffee maker classes, or different coffees, we can just override them simply by using that override with the extends. And we can use all of these tools together to make programming a lot easier in Java or in any other object-oriented programming. Thank you.